compiler 6, this is just in highlights, like it's not in depth. We'll be talking about ARM compiler 6 optimizations and all. But basically, we'll be talking about the difference between ARM compiler 5 and 6. The reason why ARM came up with ARM compiler 6. Okay, so let's start. Let me share my screen. Right. So now coming to, before starting the session, any questions, please put it on the chat window. I'll certainly come at the end of the session and try to answer them. Compiler 6 is very old, I believe probably 2020 onwards it's there. But it's a popular compiler now. It has a lot of features and advantages. So this is what we will be talking about in this presentation or in this webinar. So quick introduction. I'm Geeta. I work as director ARM tools in GSAS and SPL microsystems. We are the authorized and prime distributors of ARM software solutions in India. I have more than 25 years of experience on ARM technology, and my key strength is support. Though I take care of driving the business in GSAS. So mainly my core area is support, but I do take care of commercial things as well. This is a purely technical webinar. There is no commercial or sales talk involved. So let's get started. Okay. So coming to ARM compiler 6. So this is a leading edge C or C++ toolchain. ARM compiler, to be more precise, team, I see in the attendee list your all ARM licenses. These are the customers who are already having ARM licenses. ARM does not manufacture silicon of its own, and but the silicon vendors approach ARM and they license their IP core, and to that IP core they put their own set of peripherals and release to market as a microcontroller or a processor. It can be SoC, it can be ASIC, it can be a microcontroller unit, it can be anything. But though ARM does not manufacture silicon of its own, but they have developed the compiler, means they have invested time and resource in developing the compiler for their architecture. So, excuse me. So they have taken care of the required specific features, options the compiler should include based on the ARM architecture. Okay. So coming to this early IP availability, what does that mean? Developed alongside ARM architecture means the team at the ARM who is working on the compiler development, they also participate in ARM architecture just to know, ARM architecture team, just to know what all features, new features will be added in ARM architecture, so that the technology experts of the ARM compiler team can develop the most qualified and optimized ARM compiler support for that specific architecture. So basically, this is also used for architecture validation, and even before the silicon, even before the processor core or an MCU based on that specific ARM processor architecture is out in the market. Even before I had 9 months also, this device will be added in your compiler toolchain, so you can start working on it. So you need not wait for the device to be available and whatever the hardware to be available, so they were getting the product to the market faster. Okay. As I said, optimizations are done based on the deep architecture knowledge. So suppose people are coming with a new ARM architecture, any new specific additions or features are added, like for example SIMD, it can be, or hardware floating point unit or SVE. So some architecture extensions or features what the ARM team wants to include. So those features will be added in the ARM compiler by the ARM compiler design team. So, and the performance and the optimization, the code, whatever you develop for the specific ARM architecture also can be optimized. It generates, the ARM compiler generates the most optimized code. Optimized by the wide range of applications, not just a single benchmark. Means this ARM compiler, it can be used, or it generates the most optimized code for any real code base, irrespective of the application where the code is going on. It can be network, it can be network, um, telecom, it can be some industrial workload, it can be automotive, it can be medical, it can be anything. Irrespective of whatever the final product is, it helps in optimizing any embedded application. How it performs, it has a additional feature of performing the optimization at link time, which is called link time optimization. You got it as LTO. So when you use ARM compiler 6 for your project development, you'll be able to use this LTO, link time optimization, because as everyone knows, optimizations are performed by the compiler. But in compiler 6, in addition to the compiler 6 specific optimizations, there is also optimization done by the linker. So thereby it will reduce the code size, or it will try to generate the more optimized code. Then finely tuned ARM proprietary embedded libraries. So ARM compiler comes with ARM libraries, and this has optimized C functions, which are targeted from specific ARM architectures. And in addition to that, ARM compiler also has a micro library. Micro library was specifically developed by um, ARM for developing the code for um, for the devices which has the memory restrictions or device specific constraints. Like for example, if you take a microcontroller or RAM processor which has only on chip memory, and there is no provision to extend the memory, it means there is no provision of connecting the external memory interface or external memory chip onto the hardware. So that time this microlib option will help to generate a most optimized in the compact code, so that the code can shrink the code size, and can excuse me, and can sit in the on chip memory. It can fit it in the on chip memory. So this microlib not only reduces the code size, it also reduces the size of the library. As you know, in ARM compiler, when you develop the code, either you can generate the debug code or final output code, which goes to your hardware, or you can generate a library code. Even for library size also, you can use this compiler to reduce the code size. Okay. Sorry. Suddenly my throat is bad. And 10% faster than previous generation across EMBC. So hope the team is aware what is EMBC. EMBC is it's a benchmarking suite, which usually companies developing the embedded compiler usually do their benchmarking with the other compilers. And here, before ARM compiler 6, ARM compiler 5 was into existence. Now also ARM compiler 5 is still there. It is not obsolete. But compared to compiler 5, this ARM compiler 6 generates more 10% faster code. This speed can vary based on what workload and what is the benchmark which is done on the specific workload and what was the CPU. If you take Cortex M7 or Cortex A, the workload based on automotive, there was 10% faster, and based on some networking application, it was 40% faster. So basically, depend on the type of workload, area of what is the area you're trying to do the benchmarking, which is telecom or automotive, industrial, networking, and on which specific core. Okay, you cannot do the optimization on M0. Yes, we can do at M0 plus M0 also, but we'll be doing the benchmarking on the higher end, like M7, Cortex A, and all. Next, market proven tools you can depend on. So as you know, from the day ARM architecture, ARM course existed, it is being used for developing the code, and the code has been shipped in million of devices. For example, if you take our smartphones, now each and everyone, we have a smartphone. So the million lines of code which is gone into the smartphones is again based on ARM processor core. And the code is compiled with ARM compiler 6 or ARM compiler. Okay. Next, coming to taking embedded to the next level. So why at all ARM came up with compiler 6? Basically, before ARM compiler 6, ARM has compiler 5. So compiler 5 was supporting only um, ARM 7 based, ARM 9 based, and ARM Cortex ARM version 7 architectures, like version 7A, version 7R, version 7M. So what are these? These are architectures, nothing but 32-bit architecture cores from ARM. So let's to say compiler 6 was developed to support 64-bit processor cores, which is, you can see here, ARM V8. So for supporting this V8 based processor cores, or to develop the code, software development for the ARM V8 based architectures, ARM came up with ARM compiler 6. So as you know, as and when this technology is expanding, software development cost is increasing, the time to generate the code is, the generate application code is very less, and you have to generate a most optimized code in the less amount of time, and the device what you use is more complicated, then ARM compiler 6 would be the better choice. ARM compiler 6 supports all ARM processor cores, ARM 7, ARM 9, including all the ARM processors code till the date whatever ARM has released. Okay. Next is it supports C++ 11, C++ 14. So basically, I believe this is the only compiler toolchain which supports this C++ extensions, C++ 11 and C++ 14. So performance, as I said in the previous slide, we have link time optimization, this EMBC benchmarking, which they have done, which is increasing the code space, increasing the 10% faster code. Diagnostics. Diagnostic is something, compiler diagnostic, which will help the user to develop the most quality code and try to fix the critical errors which may create an issue at the time of deployment of the code on the board. So leading ARM V8 support. So ARM compiler 6, as I said, was developed for supporting the version 8 architecture. So in version 8, we have V8A, V8R, and V8M. So ARM, okay, advanced risk machine. So ARM V8 is a 64-bit processor core. It has support for ARC32 and ARC64 instruction sets. That ARC32 is for still the 32-bit instruction sets which was implemented for Cortex A series. That is A8, A9, whatever we have, A15, 32-bit instruction, 32-bit processor cores. And ARC64 was specifically for 64-bit processor architecture. And it has support for all the 64-bit architecture cores, can be like Cortex A35, A55, A73, A53, A75. So if you want to know the list of the devices supported by ARM compiler, if you visit developer.arm.com, please keep this site handy. You'll get all the information about the compiler, supported architectures, debuggers, evaluation boards, tools, all the information you'll get it in developer.arm.com. ARM V8M. So V8M, you may tell V8M is not 64-bit architecture. It's correct. V8M was specifically designed by ARM for only few processors like M23, M33, M55, M85, specifically for IoT applications. Because for IoT, security is the utmost concern there. Data is vulnerable for hacks by the hackers. So to avoid that, the security was built in the architecture core itself. So that security is nothing but the trust zone. So trust zone, as you may know, it was already there for Cortex A series, which was now that was extended to VM. So, but still V8M comes under 32-bit architecture core only. So V8M is not 64-bit architecture core. Okay. Then advanced language support, as I said, we have C++11, C++, 14 extensions, because ARM compiler 6 is it's a C or C++ compiler. You can not only develop the code in C, you can also develop the code in C++, and these extensions are also supported in ARM compiler 6. So coming to performance, it's optimized for real code. ARM compiler 6 is benchmarked not based on the specific application, it is benchmarked across the various domains of application, as I highlighted. Oh, sorry. Oh, just a second. Let me share screen. There's some issue. So, like I said, this is not optimized specific to the application. This is optimized. It's optimization. Is compiler performs optimization based on the real code basis, which is across any application. It can be automotive, industrial, networking, medical. Okay. We do have link time optimization, which was not there in ARM compiler 5, but was there in compiler 6. But if you want to still fine tune the optimization, you can compile your code with a -o max. This is for getting further optimized code. Then core specific optimization, because compiler team, the technical experts of the compiler team work alongside the ARM architecture team. So thereby they will be able to implement the core specific optimization. Is based on the ARM architecture code. What specific optimizations can be implemented? Such core specific optimizations can be done, but this can only be possible only if the compiler team has the deep knowledge about the architecture. Like for example, for Cortex R52, this instruction scheduling, they are able to do the optimization by giving the 9.6 performance boost. Okay, this I already told. So this is comparison between ARM compiler 6 version compiler 5. Okay, as I told, here benchmarking is done across the different workloads, whereas compiler 5 is benchmarking is done based on specific code, embedded code. So if you take Dicestone core mark for Cortex M7, you can see there is an increase of 4.92% compared to compiler 5. For automotive and industrial application, this is the workload. Automotive workload or industrial workload to be benchmarked on M7 is 43.42. Consumer is this much, networking, telecoms. So you can see it's everywhere positive. Now coming to now doing the benchmarking for compiler 5 on M0, blue color, and that brick red is Cortex M4, same application, Blinky application on M0 plus and M4, but without floating point unit. You know, M4 has a floating point unit in the processor core, but it is implementation specific, means the semiconductor vendor like NXP, ST, they'll decide whether the floating point has to be implemented in the processor core or not. It is implementation defined, or it is implementation specific. Okay. So this big red color is M4 with no floating point unit. So here you can see for CAN they have done, for USB they have done. So absolutely no or zero compromise with quality and efficiency. So here you can see get more code into memory, because this tries to shrinks your code, tries to optimize the code, size of the code. So more of your instructions can go to your memory. So here you can see for RAM and ROM, there is a 30% a decrease in the RAM size and 48% decrease in the ROM size. And this benchmarking is done with ARM compiler 6.6, okay, with the linker time optimization, which is using ARM compiler with the compiler optimization 01. You can see dark blue is for GCC compiler. So please don't take this GCC compiler as a normal GNU compiler. It is actually also invest time and money in their own compiler. We call it as Linaro GCC. So they have done benchmarking of their commercial compiler, ARM compiler with the Linaro GCC. So ARM compiler 6 is getting more code into memory, faster code where it matters. So here they have now again compared between ARM compiler 6.6 and GCC 6.2. And also ARM for all new designs recommends the customers to go with compiler 6. Okay, so you can see 121.2% faster for automotive and industrial application. Comparison to their Linaro GCC, consumer is 134%, and for office related application is 101. So there is absolutely no compromise on quality and efficiency. Next, coming to compiler diagnostics. So here, like this program is written in C++ compiler. Here there is a condition. Based on this condition, as printf, it is supposed to be equal to B, but here it's like A is equal to B. It's like a normal statement or an expression. So this it gives us a warning. It's not an error, but compiler diagnostics, as I said, will help you to fix some critical errors and improvise the quality of the code, which may create the serious issues at the time of deployment of your code onto the hardware. So usually users, what they do, okay, build completed with 0 errors with 250 warnings. They're happy because error is 0, but ARM compiler, that is ARM license linker, is able to generate the final output file and they're happy. But they don't understand the logical issues which will happen at the time of debugging or at the time of executing the code on the real hardware. So never ever ignore the warnings which are given by compilers. In this case, you can see it's a warning, it's not an error. Okay. If you look at the warning correctly, it will also tell you the note what you have to do corrections for that specific warning to overcome that warning. So these are the diagnostics which have been implemented in ARM compiler 6, which was not there in compiler 5. So now we come to the interesting part. In a one slide, comparing compiler 5 and compiler 6. So compiler 5, you can see all pre-Cortex families, which is Cortex ARM, excluding ARM-V8, means V7A, V7R, V7M. Pre-Cortex families means before ARM came up with Cortex architecture series, they were supporting ARM7, ARM9, ARM11. ARM11 did not come to embedded application. It went for enterprise application, for Java-related applications. But even before Cortex was released, ARM7, ARM9, everything is supported in compiler 5. Whereas ARM compiler 6 includes all, it supports all the processor cores, whatever the ARM has released till the date now. Compared to the supported languages, it has C90 support, C99, C++, C++11. Here we have including that with the additional features. Next, this is important, GNU compatibility. Why GNU? Why did ARM maintain this GNU compatibility? Because ARM compiler 6 is a LLVM compiler, means ARM compiler 6 was designed under LLVM umbrella. LLVM is your low level virtual machine. Your GNU compiler comes there, your Linux comes there. It's all open source. So under LLVM technology, ARM compiler 6 was developed by the ARM and they maintained GNU compatibility. So 90 to 95% of the GNU compiler options are supported in ARM compiler 6. And the assembler which goes as part of your ARM compiler 6 is nothing but the gas assembler, which is nothing but the GNU assembler itself. When I talk about compiler 6, don't think it's only compiler, it's a entire tool set. Compiler, assembler, linker, library, everything. Okay, GNU compatibility. Why GNU compatibility? Because if any, because GNU is an open source and customers tend to use open source maybe to reduce their cost, overall cost, or due to budget constraints, they're not able to afford a commercial license or whatever. Such customers, if they're developing some product which needs the safety certification or the product goes to automotive, medical, industrial, or railways. Then maintaining this GNU compatibility means you can easily get the code, whatever you developed in GCC compiler, to quickly migrate to ARM compiler 6 with the least modifications. You need not modify the entire code. Very few modifications, you can get your code. And once it's come to ARM compiler 6, some versions, I'll tell you what are those versions which are certified version. We also have safety certified versions of ARM compiler 6. When I come to that slide, I'll talk to that. You can easily get to commercial license compiler, and you can compile it and you can get your code certified, your product certified, and get the product to the market faster. Okay. So link time optimization was there in ARM compiler 5 as well as in ARM compiler 6. Maybe the advanced version of LTO was implemented in ARM compiler 6. Function safety qualification, you actually ARM compiler 5 and compiler 6 both are safety certified by TUB SUB for developing the code for safety critical applications. Okay, now let's see what are the value added values of ARM compiler 6 comparison to open source. So here they're comparing compiler 6 with GCC and LLVM. So ARM compiler 6 is very well integrated and validated with the DS5. DS5 is Development Studio 5. Now this is succeeded by Development Studio. DS5 is obsolete from September 2019, and from then Development Studio has come into picture. But the projects developed in DS5 are still supported in DS. So DS supports compiler 5 and 6 both. So early support for unsupported architecture, yes. Diagnostics both have. Performance and optimized library, yes. Compiler 6 and all this scatter loading commercial license because GNU is open source commercial license, and this is being developed, maintained, and supported by ARM. So coming to functional safety, as I was telling, ARM compiler 5 and compiler 6. So compiler 5, we had lot of versions like 5.05, 5.04, 5.06, 5.07, like that. After that, ARM compiler 6 came into picture. So in ARM compiler 5, 5.06 for the specific version which ARM selected for safety certification. So in ARM compiler 6.6 version was selected by the ARM for safety certification. So in compiler 5.06, the qualification was for ISO, that is ASIL-D. ASIL-D is your automotive safety integrity level, which is the highest safety integrity level for automotive. And 6.508 SIL-3, this is for industrial automation, industrial or a general safety lines. Whereas AC 6.6, which is ARM compiler 6.6, not only supports automotive, it has EN 50128, which is for railways, IEC 6.508 for general safety standards, and IEC 62304 is for medical. Okay, all this new support was added in ARM compiler 6.6. So core support FuSa, it supports only 32-bit architecture cores. This supports all 32-bit and 64-bit architecture cores. So functionality, we have latest LTO. Main thing is GCC compatibility and the good diagnostic information. So license, you can get this as part of term or perpetual. Then you may ask me, do I get ARM compiler 5 license? Yes. For this, you have to either purchase the MDK software, Kyle MDK software, or ARM Development Studio to get the access to compiler 5. Whereas compiler 6, you can just purchase as a standalone, so you need not purchase any software. You can purchase as a separate license, and you can either buy the subscription license or the permanent license. Okay. So now coming to ARM compiler 6 qualification. So why should anyone go for certified version of ARM compiler 6? So this reduces risk of defects in the compiler. So it will be useful to analyze for the purpose of analysis, development, and verification process. This is for the part of your the tools qualification or your code qualification or your product qualification cycle. And the process is mapped as per the V model. V model we usually use for testing and verification purpose. This process is mapped as per that. And you can also analysis of the known safety related defects. Suppose if you find any issue in the compiler, suppose you're working on compiler 6.6, you found some bug in the compiler, so you can reach out to ARM team and they'll give you a patch or they'll give you a workaround which you can use it for your application. It also has been backed up by long-term maintenance. What is long-term maintenance? We'll see here. So long-term maintenance is basically whatever the product you are developing with a specific certified version of ARM compiler. Usually the project development, then the product certification may not complete in 1 year. It may go more than 1 year. So ARM has given LTSM, long-term maintenance. Okay. So this is guaranteed 5-year maintenance from the start of, suppose ARM 6.6 compiler, ARM has released. Okay, so that's that specific version. ARM has safety certified. Okay, after that, any issues they get in the span of 5 years, any issues or defects, the customers come back, they'll release a patch for it and they'll release a different version of okay, they'll release a different version. We can see here ARM team, for compiler team, they maintain 2 different divisions of compiler. One is ARM compiler for embedded like 6.6, 6.7, 6.8. Now then we had 6.12, we had 6.17, 18, 19. Now 6.22 is the latest version. So 6.6 they selected. Okay, 6.6 was the safety certified version. So this path usually used for any new code for the latest compilers to be added, new features added, new optimizations added, new cores added, or any bug fixing happening from the older version. Everything is done in this track. But if ARM has selected AC 6.6, 6.6 ARM compiler is for safety certified compiler version, then any critical errors which the customers come back to them, so they release the patch like this. This is all for critical defects only. So you have 6.6.1, 6.6.2, 6.6.3. So like this goes for 5 years of maintenance. So up to 5 years, whatever defects, critical defects ARM comes across, maybe probably by their own analysis, or if customer comes back with some issue, they'll try to fix it and they'll release a patch. So this is also extended versions of 6.6, 6.6 patches. Okay. After 6.6, the version which ARM selected for safety certified is 6.2. So never confuse between this progressive branch and the stability branch. So to be more precise, I'll show you this before I go to the last slide. Go to develop and go to compilers. Sometimes this site becomes very slow. Okay, it's coming. So here you can see ARM compiler for embedded. Then ARM compiler for embedded FuSa. So this ARM compiler for embedded is your progressive branch, what we saw in the slide. Okay, ARM compiler for embedded FuSa is your one compiler from the progressive branch and its extension, which is the stability branch. Okay, these two are different. So embedded FuSa has only those compiler versions which are safety certified by ARM. Okay. So now, usually, as I said, because ARM compiler is safety certified, so there should be some certifying authority, right, to tell that this particular tool or specific version or RTOS, whatever is safety certified. So it is TUV SUD, or TUV is the firm which has certified the ARM compiler for safety standards, for developing the code for safety standards. So usually for some customers who are working on safety critical applications, we We give them the TUV SUD certificate indicating that ARM compiler has been safety certified. But sometimes some customers, irrespective of the certificate, they ask for the evidences. So what are those evidences? So it comes as a ARM compiler qualification kit. So this kit comes with safety manual, defect report, test report, development process report, end user generated evidence. So safety manual is basically what are the safety steps you have to take for the developing of your code using this certified version of ARM compiler. Defect report is basically whatever the defects the ARM team has fixed up for the safety certified version based on the customer feedback or by their internal analysis. So test report is suppose ARM compiler has been certified for ISO 26262 ASIL-D. So as per the standard, maybe it has some guidelines. So what any deviations each ARM compiler has taken in comparison to those guidelines, and whether that is being safe for you to implement, for you to access it, or those deviations what ARM has taken is more critical for you. Like this will give you the information on the test report and development process report. How the ARM compiler tool went, what was the procedure used, or the which ARM compiler went through to get that compiler safety certified. So this brings me to the end of the presentation. So any questions? Any questions? Okay. You can as well send me an email to Geeta at Jesus mspl.com. Any technical information, or you want to purchase the license, or you want some information based on your project, any architecture selection, everything, I'll be able to help out. And this is my number. Okay. So any questions? So no questions. Okay. Thank you, team. Thanks for your time. I'll see you soon next month because I conduct technical webinar every month, specifically on the ARM technology. It can be in the compiler, architecture, or latest trends which happening, latest technology updates, everything related to ARM. I'll be presenting. Okay. Thank you so much. Thanks for your time. I appreciate your time. See you soon next month. Thank you.